Hello dear students, welcome to chemistry class. In this class we are going to discuss about the dipole moment. And already we are familiar with the types of chemical bonds. The first one is ionic bond and the second one is covalent bond, correct? Now we have studied two types of chemical bonds, ionic bond and covalent bond. Ionic bond is nothing but the chemical bond which is formed by the complete transfer of one or more number of electrons from one atom to another atom, and hence as a result of the transfer of electrons, the atom which loses the electron will get a positive charge and that which gets electron appears a negative charge, and there exists an electrostatic force of attraction between these two oppositely charged ions which result in the formation of a bond between them, and this bond is called ionic bond. This bond is called what? Ionic bond. For example, NaCl. Okay. Then covalent bond means what? Here the sharing of electron takes place by the combining atoms. Here A and B are the combining atoms, means here A will also share one electron and B will also share one electron, and which results in the formation of a bond between these two combining atoms, and here the bonded electron pairs are belonging to both the combining atoms. Here the bonded pair of electron is belonging to A and as well as also B. Okay. Then again in covalent bond we can classify them as non-polar covalent bond and polar covalent bond. Again covalent bonds can be classified into non-polar covalent bond and polar covalent bond. Non-polar covalent bonds means the molecules which are forming of this type AA or BB, or we can say the for example for this we can write homonuclear diatomic molecules. Homonuclear diatomic molecules of the type H2, which can be written as H is forming a bond with H, and here the bonded pair of electron, here these molecule H2 molecule is formed by the sharing of one electron from each of these hydrogens, and the bonded pair of electron is present at the middle or at the center, exact center of the bond, or at the middle position of these two internuclear atoms. Okay. Or we can write Cl2. Here also the bonded pair of electron is present at exactly the central position or the mid position of the bond, and these type of covalent bond or the molecules are called non-polar covalent molecules. And here both the combining atoms have same electronegativity, means same affinity for the electron pair. Therefore, this atom is also attracting the electron and this atom is also attracting this electron pair with the same amount. This is also attracting with the same amount and this is also attracting with the equal amount of force. Therefore, the bonded pair of electron will remain at center of the bond, and therefore, these are called non-polar covalent bonds. And in polar covalent bond, it is of the type of AB, means heteronuclear diatomic molecules are the best examples for a polar covalent bond. Take for example HCl, and here this molecule is forming by the sharing of one electron from the hydrogen and one electron from the chlorine, and here we know that this chlorine is more electronegative than the hydrogen. This chlorine is more electronegative than the hydrogen, therefore, it will attract the bonded pair of electron towards itself. Then hence here as the bonded pair of electrons are moving or migrating towards the chlorine, this chlorine will get a partial negative charge and this will get a partial positive charge. This chlorine, which is more electronegative, will drag the bonded pair of electrons more strongly towards itself, and hence it gets a partial negative charge and it gets a partial positive charge. Even though this is a covalent molecule and this bond is forming by the sharing of an electron, the charge separation is taking place in this one. Positive and negative charge separation is taking place, therefore it is called what? Polar covalent molecule, and the bond is called polar covalent bond. Why? Here two poles are there, two poles are there, dipole, two poles are there here. Okay. This is what a polar covalent bond. Then if we consider another one, A, B, C, D. Here B is more electronegative than the A and it is having a partial negative charge, and this one is having partial positive charge. And if D is more electronegative than the C, then it is having partial negative and this one is having partial positive charge. This is also polar and this is also polar. Then now how can you say how much polar this AB as compared to CD, or in these two which one is more polar, which one is less polar? Then to judge that one or to determine the magnitude of polarity induced in a polar covalent molecules, one unit existed, that is dipole moment. This dipole moment is nothing but a unit or a quantity or a parameter which will determine the polarity in a polar covalent molecules. Polar covalent molecules. Then let me explain about the dipole moment. Okay. This dipole moment can be represented by the symbol mu, and it can be defined as a product of charge into the distance of separation between the combining atoms. This dipole moment can be defined as the product of charge on any one of the atom as a result of polarization and the distance of separation between those two combining atoms. We can write a definition for this dipole moment defined as the product of charge on any one atom and the distance of separation between the charges. This is the definition for dipole moment. This can be defined as the product of charge on any one atom and the distance of separation between the charges. Say if polar covalent molecule A, B is there, and here B is more electronegative than A, means it will get partial negative charge and this one will get partial positive charge. And we know that the symbol for charge is Q, therefore here I am writing this one as a plus Q and this one as a minus Q. And here I am considering this one the separation of unit charge. Unit charge is separating here, means one charge is separating here, therefore I am writing here plus Q and minus Q, and these two atoms are there at a distance of d. Then the dipole moment for this polar covalent molecule AB can be defined as the product of charge, that may be a plus charge or minus charge and the distance of separation between those two charges. Okay. And now we can write the units for this dipole moment, the SI unit and the CGS unit. The SI unit and CGS unit. Then what are the SI units for charge? And here I am writing the units for this dipole moment by considering the charge Q as a 1 unit, that is a charge of 1 electron, and the distance of 1 unit, that is of 1 angstrom. if the polar covalent molecule AB is separating by a distance of 1 angstrom and the charge separation is taking place on each atom as 1 electron, then the unit for that polar covalent molecule or the dipole moment can be written in SI as well as CGS system. CGS system means what? Centimeter gram second system. And the SI unit for charge, the SI unit of charge is coulomb, and here the charge is 1 electron, therefore its SI unit is 1.6 into 10 raised to minus 19 coulomb. What is the CGS unit of charge? 1 electron is nothing but 4.8 into 10 raised to minus 10 electrostatic unit. In CGS system, 1 electron charge can be written as a 4.8 into 10 raised to minus 10 electrostatic unit. Then in SI unit, what is the SI unit of distance? Here we are taking unit distance. Then in SI system, the distance unit is meter, 10 raised to minus 10 meter, 1 angstrom, it is equal to 1 into, and in CGS system, the unit of distance is centimeter. Then we can write the units for dipole moment. Mu is equal to Q into D in SI system. What is the value of Q here? 1.6 into 10 raised to minus 19 coulomb into 1 into 10 raised to minus 10 meter, 1.6 into 10 raised to 29 coulomb meter. This is the SI unit of dipole moment. The SI unit of dipole moment is coulomb meter, and the CGS unit of dipole moment can be written like this one: 4.8 into 10 raised to minus 10 electrostatic unit into 1 into 10 raised to minus 8 centimeter, 4.8 into 10 raised to minus 18 electrostatic unit centimeter, and this 10 raised to minus 18 electrostatic unit centimeter can also be written as a dB. Therefore, the CGS unit of dipole moment is dB. 1 dB is equal to 10 raised to minus 18 electrostatic unit centimeter. 1 dB is equal to 10 raised to minus 18 electrostatic unit centimeter. This is the SI unit. SI unit of dipole moment is coulomb meter, and the CGS unit of dipole moment is dB. And here we can also write, or we can interrelate these two units. 1 dB is equal to 3.33 into 10 raised to minus 30 coulomb meter. In exam, if they given in a dB and asked to calculate in coulomb meter, we can use this conversion factor. 1 dB is equal to 3.33 into 10 raised to minus 30 coulomb meter. Okay. This is all about the units of dipole moment, and this dipole moment is a vector quantity. This dipole moment is a vector quantity, and it has both magnitude and direction. Magnitude is there by multiplying the charge with the distance, and the direction we can write the direction, this is minus q plus q, from positive pole to the negative pole with this arrow which is having a cross or plus symbol at the tail. This dipole moment is a vector quantity which has both direction as well as a magnitude, and the magnitude can be obtained by multiplying the charge with the distance, and the direction is there from positive pole to the negative pole of that dipolar molecule, from positive pole to the negative pole of that dipolar molecule, and this can be represented by a symbol arrow which is having a positive symbol or cross mark at a tail. Okay. This is all about the dipole moment, and here we are all discussing the molecules of covalent compounds, as the covalent compounds are formed by the sharing of electron, there is no charge separation. But according to the dipole moment, here we are observing the charge separation only because of the difference in their electronegativity, and therefore, as there is a charge separation in the covalent molecule, we can observe there is a somewhat ionic character in covalent molecules. According to the dipole moment, we can observe somewhat ionic character in the covalent molecules only because of the charge separation due to the difference in their electronegativity. Okay. And this ionic character can be calculated by using the formula, that is a percentage, or we can write ionic character, percentage ionic character. This is also one of the application of dipole moment. By using the dipole moment, we can calculate how much percentage of ionic character is there in a given covalent molecule. This percentage ionic character can be defined as a ratio of experimental dipole moment to the theoretical dipole moment into 100. This percentage ionic character can be defined as the ratio of experimental dipole moment to the theoretical dipole moment into 100, or we can write the percentage ionic character is equal to observed dipole moment to the calculated dipole moment multiplied with 100. The ratio of observed dipole moment to the calculated dipole moment, which is multiplied with 100. And here the calculated dipole moment is that in exam they will give the observed dipole moment and they ask to calculate the percentage ionic character in a given covalent molecule. And the calculated dipole moment can be obtained by assuming 100% ionization. There is an 100% ionization taking place in a polar molecule. With that concept, we can calculate the dipole moment, and by using that calculated dipole moment and the given dipole moment, we can calculate the percentage ionic character in a given covalent molecule. And this can be also written in short like mu observed divided by mu calculated into 100. Then by using one simple example, we can calculate or we can understand what to mean by the percentage ionic character. Take an example. Observed dipole moment of HCl is HCl is a polar molecule, polar covalent molecule it is, yes, 1.03 dB. The observed dipole moment of HCl is 1.03 dB, and the bond length of HCl is 1.27 angstrom. Then calculate the percentage ionic character or percentage ionic character in HCl. They have given the observed dipole moment for HCl, and also they given the internuclear distance, that is a bond length, and they asked to calculate the percentage ionic character in HCl. What they have given? They given mu observed, that is of about 1.03 dB, correct? And also they given the value of bond length, that is a D, 1.27 angstrom. And as they are given here in a D means a CGS system, we have to convert this length in CGS system only. Therefore, it becomes 1.27 into 10 raised to minus 8 centimeter, correct? Then now we have to calculate the dipole moment by this data, by assuming there is an 100% ionic character, or there is an 100% ionization is taking place in a given covalent molecule by the theory of a dipole moment. Okay. Then how can we calculate the dipole moment for this HCl molecule? Mu calculated is given by Q into T, and as we are considering there is an 100% ionization, means there is a separation of +1 and -1 charge taking place between the combining atoms. As +1 and -1 charge separation is taking place, it is nothing but the charge of one electron. Then in CGS system, the charge of one electron is 4.8 into 10 raised to -10 electrostatic unit, correct? Then they have given D 1.27 into 10 raised to -8 centimeter. Then now multiply these two, we will get 6.096 into 10 raised to 10 8 -18 electrostatic unit centimeter, and we know that 1 into 10 raised to -18 electrostatic unit centimeter can also be written as dB. Therefore, mu calculated is 6.096 dB. Then from using these two data, we can calculate the percentage ionic character of HCl, that is mu observed divided by mu calculated into 100. Then the mu observed is 1.03 divided by mu calculated is 6.096 into 100, and it is giving the value of 16.89, which is nearly equal to 17%, which is nearly equal to 17%. Then what it shows? In a molecule of HCl, 17% of ionic character is there and the rest is covalent character. But while studying the covalent compounds, what we have studied, this HCl molecule is purely covalent, but by using the dipole moment concept, we can say there is a somewhat ionic character present in every covalent compounds. This HCl molecule is having 17% of ionic character. Then like this we can calculate the percentage ionic character for almost all the hydrogen halides. Take for example for HF, the percentage ionic character is 43%. Then for HCl, it is there as 17%. Then for HBr, it is there at 12%. Then for HI, it is there as 5%. Then here we can say the percentage of ionic character decreases down the group of the halogens. Why? Because the electronegativity down the group of the halogens goes on decreases. As the electronegativity decreases, the polarity in a given molecule also decreases. As the polarity decreases, their ionic character also decreases, which results in the covalent character. Okay. This is all about what? The percentage ionic character. Using these datas or this formula, we can calculate the percentage of an ionic character in a given covalent molecule. This is all about what? The application of dipole moment, percentage ionic character. And the next concept is bond moment. Bond moment. It can be defined as the contribution of each bond to the total dipole moment of a polyatomic molecule. This bond moment can be defined as the contribution of each bond to the total dipole moment of a polyatomic molecule. Take for example, the bond moment of OH bond in water molecule. This is a triatomic molecule, that is a polyatomic molecule, and the bond moment of OH is 1.51 dB. We know that this water is having this saphana here, the bond moment of this OH bond is 1.51 dBA, and this can be used to calculate the total dipole moment of this molecule, and this is called what? Bond moment. Thank you.